Hello, today we're going to talk about area of triangles, and we're going to first start by counting squares and using formulas. So this is a page that did not get copied in your packet. So would you look for that extra sheet, and we're going to begin. So you may notice that I mentioned we're going to count squares, and with a triangle that makes it difficult because we see some of them are whole squares, but many of them are not. And so we could try to piece pieces together to make squares, but better, there's a formula that will help us with that. So the formula for a triangle, we can use two different versions. We can start, the official formula says area equals 1/2 times the base times the height. And the base is this horizontal, well, it's not always horizontal, just on this case it is, this line, and we can see it's 1, 2, 3, 4 centimeters. And then the height is from the very highest part of the triangle down to the base. If we count from there, we have 1, 2, 3, 4, 5. So the height would be 5 centimeters. And I'm going to also put B for base here. So we could use this formula as is, but an easier way to use this formula, because 1/2 multiplying by 1/2 is the same thing as dividing something in two pieces, or dividing by 2, we can use this version of the formula. And this is my personal preference. That's what I'm going to use first, but we can talk about the other version in a few minutes. So now we know what the base is. We know that the base is 4, and we know what the height is. The height is 5, and the formula says I should divide that by 2. So 4 times 5 is 20, and then we're dividing by 2. So the area of this is 10 centimeters squared. So real briefly, I want to show you where this formula came from. If I took this triangle, and a copy of this triangle, and flipped it upside down, and then set it next to this, I would have a parallelogram on my hands, and that's area equals base times height. Half of this would be that triangle. So now when we go to try to count the squares, though, it might be a little bit easier if I think about cutting this triangle in half right there. If I cut it in half and then took this piece right here and I turned it upside down and attached it here, let's see if we have 10 squares. So I'm just taking that piece that I cut off, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we do indeed have 10 centimeters squared. If we kind of cut this triangle up and kind of rearranged it and put it together, we would have 10 centimeters. So let's move on to the next type of triangle. And by the way, this particular triangle we just worked on is an isosceles triangle because both of these sides are equal in measure, and that's what makes it an isosceles triangle. This next triangle is what's called a right triangle. And a right triangle has a 90-degree angle, and the base of this one is this line, but the height is also one of the sides. You may have noticed in our last figure the height was kind of inside the triangle, the highest point, but on a right triangle it's also part of the sides, or it's part of the triangle. In fact, we call those legs. And so this is 4 centimeters, the height, and the base, well, let's count. We start here. When we start at this point, we don't count until we move. So 1, 2, 3, 4, 5, 6 to get to this tip, and that's 6 centimeters. So we're going to start with 1/2. This time we'll use the other formula, times the base times the height. So we're going to keep the 1/2. We're going to take the base as 6, and we're going to take the height as 3. And now we have choices. We can just take them in order. So 1/2 times 6. If you recall, we would take 1/2 times 6 over 1. We'd make them both into fraction form. We would multiply straight across. It might be a while since we've done this. And this would be 6 as the numerator and 2 as the denominator. Well, 6 divided by 2, or if we also took 6 and divided both of them by 2, we would get 3 over 1. And in that case, it's 3. So these two numbers together are 3. Then we have this other 3 that we haven't used. So the area of this triangle would be 9 centimeters squared. So let's look at the other way to do this formula just real briefly. If I took area equals 6 times 3 and I divide it by 2, that would be 18 divided by 2, and sure enough, that would be 9 centimeters squared. So let's look at our final triangle. So I'd like you to see what you can do with this. This is the base. The highest point is from here to here. What do you think the base is, and what do you think the height is? If you said the base was 7 centimeters, you're correct. So let's double check. That's our starting point. So 1, 2, 3, 4, 5, 6, 7. And then the height is 3. So we're going to start. Again, my personal preference is base times height divided by 2, but you can do whichever you prefer. That would be the base of 7 times 3, which is the height, divided by 2. And area equals 21 divided by 2. Now this time it's not an even number. So we would take 21 divided by 2. 2 will go into 2 one time. Take away the 2. We drop down the 1. 2 will not go into 1, so we're going to have to put a 0. And now we're going to have to go into our decimals. So I'm now going to put a 0 here, attach a 0, drop it down. We're pretending this is 10 instead of 1, and 2 will go into 10 5 times. And so it terminates, meaning it ends. So the area of this is 10.5, 10 5/10, or 10 1/2 centimeters squared. Now let's continue with our practice without the centimeters. So this is page 9, this is page 10. And so we just got done discussing that there's two ways to write the formula, 1/2 times base times height. This is what you'll probably see if you look up the formula. Or base times height divided by 2, because multiplying by 1/2 is the same thing as dividing by 2. When we do this, we always want to get in the habit of showing the formula, the substitution, that means replacing the numbers, and the calculation with unit labels. So this time we do not have the benefit of the squares, but since we practiced the formula a couple times before, we should be able to do this. So I'm going to do this first one with you and then ask you to complete the other two on your own. I'm going to start with this formula, and then so we have the formula, check. We have the dimensions labeled for us, so that's nice. I see the base is 14. I see the height is 8. And then after I do that, I'm going to divide by 2. So would you please use your calculator? 14 times 8. So that would be 112 divided by 2. And so the area is 56 centimeters. Oops, excuse me, this is inches squared. By the way, we could, if we wanted to, we could take either 14 divided by 2 or 8 divided by 2 and then multiply by the other number. If I took 14 divided by 2, I'd get 7. And 7 times 8 would be 56. That's another way you could approach this. So would you please do the rest of the the problems on your own, and we'll check back when we get together in class. Thanks for watching, and have a great day.